This is the ECON climb speed. It is the commanded speed if the economy mode has been selected and there is not a waypoint speed constraint, speed restriction, or transition altitude speed restriction active. This speed will provide the minimum total trip cost based on the cost index entered during FMC initialization. High weight or high cost index will result in a higher ECON climb speed. As the airplane climbs to a higher altitude, the climb is flown at a constant Mach number. The FMC will select the ECON cruise Mach number. This eliminates acceleration or deceleration in the transition from climb to cruise. Once attaining altitude, the FMC will fly the ECON cruise speed. The ECON cruise speed is a function of cost index, gross weight, altitude, and actual winds. This speed will change during the flight as fuel burns, the wind changes, or if a different altitude is selected. This speed can vary from a low of the maximum range cruise speed, MRC, at a cost index of 0 to the VNAV limit or cruise thrust speed at a high cost index. Since MRC is the maximum range cruise speed, flying this speed results in the minimum trip fuel and therefore the maximum range. This occurs at the speed where the fuel mileage is the greatest. Another speed you may be familiar with is LRC, the long-range cruise speed. This speed is defined as the Mach number where the fuel mileage is 99% of the maximum. Flying at LRC results in a 10 to 25 knot increase in ground speed for about 1% increase in trip fuel. On the 737-800 airplane, LRC is approximately a Mach number of 7.7 when cruising near optimum altitude. For example, increasing the speed from 7.7 to 7.85, about 10 knots, will increase the trip fuel by about 4 to 5% at normal cruise conditions. At high cost indexes, the airplane's speed may be limited by the VNAV speed limit or the cruise thrust limit. The VNAV speed limit is VMO minus 5 knots. The cruise thrust limit is the speed where the thrust required for level flight equals the maximum cruise thrust available. As temperature increases, the cruise thrust limited Mach number will decrease. After the top of descent, the vertical descent path necessary to meet the first altitude constraint on the legs page at idle thrust results in the descent speed. The target speed is displayed for planning purposes only. As the airplane descends, the highlighted speed will change from the target Mach number to the target IAS. This crossover occurs when the IAS exceeds the target Mach number as the result of the change in altitude. The target IAS is a function of the cost index only.